Hello guys, here we are with question 5. So we have two forces, F1 and F2, acting on a particle A. F1 is 2I minus 3J, and F2 we don't know, so that's PI plus QJ. We do know that the resultant of them is parallel to I plus 2J. So let's write them down as vectors. We don't have to, but that's what I would prefer. So we have 2 minus 3 plus PQ, which would give you 2 plus P over Q minus 3. And now we know it's parallel to I plus 2J. That means that the J component is double the I component, which tells us that Q minus 3 is double 2 plus P. So if we take everything onto the right hand side and multiply our brackets, we'd get 4 plus 2p minus q plus 3, which gives us that which is required, 2p minus q plus 7 equals 0, QED. Okay, part B, next 5 marks. We are given that Q is 11. Now, what they're doing when they're telling us that Q is 11 is they are actually telling us what P is as well, because we have this equation that we found in part A. And if we take our variables onto the constants onto the right hand side, we end up 2P is 11 minus 7, which is 4, so therefore P equals 2. This allows us to find this, our resultant. So our resultant force will be 2 plus P, which is 4, and Q minus 3, which is 8. Now, we know that force is equal to mass times acceleration. So our force, resultant force is 4.8. Our mass is 2, and our acceleration, let's call it AB. So we're going to divide by 2, so therefore AB equals 2, 4. So we want the magnitude of that, so that means 2 right and 4 up. So to find the magnitude, we're going to use Pythagoras. So therefore acceleration will be equal to the square root of 4 squared plus 2 squared. So that's 16 plus 4, which is 20. So root 20, which is root 4 times root 5. So we can write that as 2 root 5. There we go. 10 marks.